Sure.
Good to start? Okay. All right, so welcome again, everybody. First session for tonight, opposites attract. So yeah, a story of running Linux on Windows, as Wim already indicated, a penguin with some love for Windows or vice versa. Speaker introduction, who am I? My name is Tim de Keuklare. I'm based in Ghent. I'm a consultant working for SecWise. I've been active in the community for quite some time. So yeah, I'm pretty active on social media as well as part of that. So you can connect with me, follow me on Twitter, connect on LinkedIn, have a look at my blog. You can reach me through email. My email address is on there. So if after this session you have any questions or would like to reach out, any of those will allow you to contact me. I'm not alone to present this session tonight. I'm here with Ken Hoses. So Ken, if you can introduce yourself.
Sure. Hello, good evening. So my name is Ken Hoses. I'm a program manager at Microsoft, and I am presenting tonight together with Tim this session about the Windows subsystem for Linux. I'm mainly focused in my day-to-day business on Endpoint Manager, same as Tim, obviously, or the M365 workload. So doing this today is kind of different for us, and it was a great experience. And yeah, happy to have this talk with Tim about the Windows subsystem for Linux. Welcome. For the agenda today, first we will talk a little bit about the intro. What is the Wsl? What is the Wsl architecture? How did we evolve? How did we go from Wsl 1 into Wsl-2? And what are some upcoming features? So what is next? And then we will have some time eventually to have some Q&A. So please stay tuned and focused. Thanks.
Okay, let's get started with an introduction. Ken, are you gonna? Okay, yeah. So WSL, what is it? Well, the typical scenario would be, for example, a developer is working on a new application in a specific platform, and to do that work, to do the testing, to do the compiling, you need the right tools. And most likely those tools will work on a specific operating system, the one that you're using right now. Maybe that's Windows, maybe that's Linux. But if you have to switch to the other environment, well, those tools, they might not work so great anymore, and you would have to switch platforms entirely. So what we're trying to do here is create a situation where you don't have to switch anymore. And wouldn't it be great if you could use any of those tools on the platform that you're working on right now? So what is Microsoft trying to achieve with the WSL, so the Windows subsystem for Linux? They want to give you choice and flexibility. So you can, you're allowed then to run native Linux libraries as runtime code, and it's giving you the choice to use a Linux or a Windows environment at the same time, whatever suits you best at that moment. So whether you run Bash and you want to run Windows executables as needed, or you run Windows and you want to run Linux commands, that's all feasible. So yeah, if we can move forward.
Yes.
How do we install this? Well, for most of us, it's actually already available. It's an optional feature that you can enable on a Windows 10 device. And like any optional feature, you can do that either through the GUI or by using PowerShell. We'll run to both methods. Ken is apparently trigger happy. So first we need to install the optional feature, and then the next step that we need to do is we need to go to the Windows Store and pick our favorite distro, because there are multiple options, but we'll get to that further down the deck. Yeah. So installing through the GUI, rather simple. You go to the control panel and turn Windows features on or off. If you go to the bottom, you'll find there the Windows subsystem for Linux. Just enable it, and you'll have to do a quick reboot after that, and you're good to go. That's the first method. Now, if you are familiar with Linux, maybe you want to do things through a command line. Well, we can also use PowerShell here as well. So if you run this command via PowerShell, you also get the feature installed. Also here, do a quick reboot, and you're up and running and good to go. So that's part one, enabling the feature. And then part two, as I mentioned, then we need to go to the Windows Store, and you can choose or look for a distro. I think in most of our demos, we use Ubuntu, but for example, there is also Debian, there's Kali, there's other distros available as well. You just need to click the Get button in the store, and it will get installed on your system. That's all it takes. These two simple steps, and we're good to go.
Correct. And then if we take a deeper look at it or a closer look at it, we have our Linux subsystem. And the cool thing in the Linux subsystem, in my opinion, is that that it is actually an existing Linux file system. So, for example, if I do my ls minus LA, I see that I have a complete Linux file system on my Windows computer. In a matter of fact, it is part of Windows, so it means, as you can see, that I can mount to drives that are on Windows. And that is particularly very important here, that I can store all my files on the Windows, because for whatever reason, and I will elaborate on that later on in the session, for whatever reason that you disconnect your distro or you lose a connection to your distro, the files, the information is basically gone. So there is no like save options within the distro itself. So that is very important. You need to save the files on an external location. Now, with screen fetch, we can easily see which kind of version we have. And we can see here that this is one of the Ubuntu's 20.4 focal version. So it's really on the Windows subsystem for Linux, and it gives me information about my CPU, my memory usage, and so forth. It's also a cool thing you all know, or people that have been living in Linux for a way, is that we can use some cowsays, which is super nice. It's like a joke within the Linux community, that you can basically repeat this command and you will have, or should have, at least some jokes. I'm not sure. Did I miss cowsay? No. Okay. So usually I get a message here. Not sure why this is not working. I'll probably be
small caps here.
Yeah, indeed. Yeah, I thought so. So yeah, it is cap sensitive or case sensitive. So there we go. Yeah, your business will assume vast proportions, and every time I have another joke. So this is, yeah, a small thing, really fine. What we also can do from within the subsystem for Linux is immediately accessing a Windows process. For example, the notepad.exe is one of them. So I can now type immediately here. This is a test or whatever. I can save it in a location in my Windows. We can even do more. For example, if you want to start writing code directly, we can create like a new file, and then code will open, and I have a new Python file where I immediately can start to write my own code. So this is super easy because I can switch back and forth from Linux into Windows without a minimal amount of effort. I don't need to spin up an entire environment. It's just very easy for me to write my code and even compile them. But that is also something that will come back later on. And that is the direction from the Linux system to the Windows, but the other way around is also possible. So basically, whenever I go into my terminal here again, and I open one of the command prompts, I can type Wsl, and it will bring me directly into my my Windows subsystem for Linux again. So this is super nice, right? And I have my Wsl Config, for example. Oh, go back in command prompt, exit, yes. Wsl Config.exe. And then I can see all the options that I have. For example, with the Wsl Config.exe/ I think it's yes, I can set the default, but therefore I need to list first what options I have. You see that I have 3 different distros here. And then when I specify the S, I can change my default distro and so forth and so further. So you can really play with it. You have a lot of flexibility with it, from Windows into Linux, but from Linux into Windows. And we will elaborate on all these technologies and the protocols that we use to get this that's working, because you translate Linux commands into Windows and vice versa. So there are some interpreters in between, which we will discuss during today's session.
Okay, so thanks for the demo, Ken. Let's have maybe have a look under the hood. What's happening under the hood when we do all this magic. So if we can go to the next one, yeah. Now, before we talk architecture, maybe first explain what we see here on the left side. What's the difference between kernel mode and user mode? If you're not familiar with that, in kernel mode, it's clear we have to understand that executing code has complete access, unrestricted access to the underlying hardware. So we can execute any CPU instruction, reference any memory address. So yeah, this is typically something which is reserved for the lowest level, most trusted functions of the operating system. If anything goes wrong here, if you have a crash in kernel mode, most likely it's a catastrophic event and it will halt the entire PC. Yeah. If we talk about user mode, it's a little bit different. The executing code has no ability to directly access the hardware or reference memory directly. So if you have any code running in user mode, it must delegate to system APIs to access the hardware or the memory. Yeah. So this brings protection, it brings isolation. So, and because of that, if we have a crash in user mode, it's commonly recoverable. It's not as severe as a crash in kernel mode. So in our day-to-day, if we run code on a computer, it will most likely execute in user mode. Yeah. So if we map this to the diagram that you see here in the top section, the green section is showing you what is running in user mode. So the Wsl config that Ken just demoed, wsl.exe, and the distro, in this example, ubuntu.exe is running there. Yeah? So all of the data in the distro itself, as you can see, it's in the green section. This is stored in user mode. Yeah? The bottom section, the kernel mode section in blue, this is actually showing you what is running in kernel mode on the machine. So the Win32, the LX Core sys, and of course the Windows NT kernel. Yeah. So if you can move one forward. So if we talk about WSL, it's a paired kernel driver and a set of user mode helper tools. So what is highlighted here. Now, commonly on top of that, inside the terminology of WSL, it also implies the subsystem and the distro of choice installed or active at the moment. Yeah. Okay. So, yeah.
Yeah, sorry.
They're happy back and forth, Ken.
Yeah.
So, okay. When we start a binary, so using wsl.exe, we can start a Linux binary. We create a custom init inside of the distro and run the binary in that session. So any calls to the system, so any calls going back to kernel mode, are handled by lxcore.sys. That's where the transition is. So any processes that we're running in Linux, if you would open up Task Manager, for example, in Windows, they would be listed there as well. So that's transparent. Yeah. So once we enable the optional feature, but what you've seen prior to the demo of Ken, the yellow components are introduced to the system. And of course, when we go to the store, if you go to the next one, Ken, then we also add our distro. Yeah, that's these are the components that are installed.
It is also possible to install multiple distros. So they are all registered into WSL, as I showed you with the command /l to list all the different distros. Now let's take a look what happens when we configure different aspects of WSL using that WSL config. So I already briefly went through them. So if we have that WSL/l, then WSL config /l. Okay, /l. Then we can see that I have listed now all my three distros here. It's super easy because now I can take again my session and I can go into Wsl config. I can say /s and I can, for example, make my Debian the default. So that means that if I go and check now on the default ones, it's the list, sorry. I can see that Debian became the default Linux subsystem for Linux. So whenever I'm going to create a new connection to my from within the command prompt here to WSL, he should bring me into my my Debian distro. I'm sorry. So going and having that availability makes it able for you as a developer, for example, to run different programs or compile different codes in different distributions and easily switch back and forth between them. Now, it is important that whenever you unregister one of the distros, so unregistering a distro can be done by doing the Wsl Config /u for unregister, and then you specify which one you want to unregister. I need to do that from command prompt, obviously. So Wsl Config /u, and then I take Debian, and he's going to unregister my Debian. So everything that I, as a user, would have been creating or created in that distro will obviously be gone. Everything will be gone. So that's why I also have this slide here. Be very, very careful whenever you unregister your distros. Make sure that there is no data stored at any time in the distro, because whenever you unregister it, it will be lost forever. So you will lose all your work. Now, to reinstall or to re-register a distro, you can run the distro name .exe, and it will automatically be reinstalled within the Windows subsystem for Linux. Now, having a good view on the architecture, let's see what we can do with Python, for example, and see what we can do in order to compile code. So whenever we start our terminal, so I have my terminal here. I will make it a little bigger. I will be able basically to use, as I did here. I can basically create a new file. I will do it again. It will probably bring me to the same file. But here I have now my main.py. My main.py is a file, is a Python file, and I can start to write code in that. So if I want to write some code, I can do import platform, print, and then hello world, like all the good programmers do the first time. I'm not a very good programmer. I need to be very, very honest here, but still. So you are running on a, and I need to put a variable here, system exclamation mark, and then I need to give it some formatting, and I want to take the platform.system. There we go. Now, this is going to give me information about the system that I'm running, but I want also to have something that tells me more about my release. So my release is, again, I need a variable filled in, and then I'm going to define it. So format platform.release. And I think I have a typo somewhere. Oh no, I missed my codes here. Yeah, so format and then platform.release. And there we go. And I need to remove this one. Yes. So one more. So now if I save this code, I have, and I return back into my terminal. Well, basically, I can easily run that now and say, okay, like, okay, I want to run it with Python 3, and I want to run my main.py. It's going to execute or compile the code. Import platform. Did I miss something? I don't think so. So let me go back to the code. It's obviously with a small letter. So this is very case sensitive. So if I now do, it will run. So hello world, you are running on a Linux system, and your release is 4.4.0 on Microsoft. So this is super nice, right? I just compiled my code directly into the Windows subsystem for Linux, and it's a code that is written in Visual Studio Code on my Windows. So I don't need to use Nano or Vim or any other Linux editor or anything else. I can just do it in Visual Studio Code directly from the subsystem. So that's super cool. We can also use this for advanced web development, for example. meaning that we can install a web server. So let's have a look. I did it already in advance. So I created a folder for my project. And in that folder, I will create another file and an environment, a Python virtual environment. I was missing that module, so I need to install the Python virtual environment first. So I'm gonna install it quickly. Need to provide my password because I have elevation, and I'll just continue with the installation. It's also using pip. So pip was not installed by default in the Windows subsystem for Linux. So I need to use some curl package manager to get pip installed on the device. So that is the next step. I tried to run a command, but it failed just because of the pip that I was missing. And then going to create the environment first. Install it. Now I'm gonna create it. But it's going. And then I will activate it. And then now I need the pip to install Flask. So Flask is actually the framework that I use to build a web server. And yeah, it's not. Voilà. So I install pip. But that doesn't work with apt-get. So now I need to use curl. So that was my lessons learned. And I didn't want to cut it out of the recording because it's probably something that a few people might hit. And here, yeah, obviously the P requires also a Y because otherwise it's not a Python file. So I had a typo there. Come on. And there we go. The cool thing is now that I have a web server that I can create multiple folders, that I can create multiple websites, and basically create my project in Python and run my web servers locally without the need of a full environment or a container or a VM. And I need to do that for a user, so install Flask is on a user level. That's why sudo wasn't working. And whenever I have this, I can start and write my my code. So then I go into the code. Just gonna speed it a little bit up. Webserver.py, and then I install also the Py extension. And let's have a look in live how that actually looks like. So if I go into my project, I have here the webserver.py. Where I basically have my Python code written that I want to have a web server running on my Windows subsystem for Linux, and I have basically two pages. One is in the and I go back to my terminal now. So I have a subfolder here which called templates, and in the templates I have a hello.html, and again with the hello.html I can write some HTML code here that will basically in the end show my my web server or give you my web service back in Windows. So if I now run Flask, oh yeah, obviously Python 3 Flask run. my projects and then code. Okay, so this is okay, and then I need to export the Flask app to my web server.py, and then Flask run. But apparently Flask is not found. Okay, that is super weird because I installed it literally before the session. So if I do pip install Flask, am I in? Okay, there are the demo gods.
You had a typo there. Again, it's pip, not pin.
Oh, sorry. Okay, you're right. But some, I don't know exactly what is. Let me go back into the, because yeah, this is my web service that shows hello world. So I like basically did it. So it should all be there. Just wonder why it's not compiling. So or that is weird. Yeah. Okay. But the idea is that that we have a web server. So as you can see here in the recording, and so as soon as I run Flask, so Flask run is really the command, I have my web service, and then I can start to play with it. So I'm not really sure why it hangs now, or what it actually does, but maybe I need to bin. Let me just try activate. Okay, let's rebuild it. So Python 3 -m -m venv. 2 seconds. It's because it's super easy actually, and I'm very disappointed that this is failing now. So I'm gonna quickly do it. Venv bin activate. Okay, and now here pip install Flask. There we go. So that was a problem. I needed to reactivate the virtual environment. You see now venv is in front of my name. So I'm actually now in my virtual environment, and that will allow me to start my my web server. So now he is, well, okay, I probably need to export Flask app equal, and that is the web server.py. And if I run Flask now, it should my project, and then yes, I have it running. So sorry for this. So, but now if I have my my web server, so welcome to another great MC2MC evening. And if I go into the naming, so I have hello from WSL. Ken, thank you. So Tim, back to you.
Yeah, thanks for the demo, Ken.
The gods.
If you can put the slides back.
Yes.
All right. So the Windows subsystem for Linux 2. All good things come by 2. So also the Windows subsystem for Linux. If you can go to the next slide. What is Wsl-2? Yeah, it's building, of course, further on the existing technology, and Wsl-2 is a new architecture. And the primary goal of that new architecture is to improve file system performance and compatibility, which were 2 points or 2 elements of feedback that Microsoft has gotten. Now, from an installation perspective, so installing a distro or enabling the features, that's all remaining the same. So bottom line, WSL2, the introduction of it should be transparent to you. Yeah, the changes have happened on the back end, so the part where Linux runs on. So it's called WSL2 by Microsoft because they have fundamentally changed how it interacts with the binaries. And therefore, Microsoft is also explicitly distinguishing WSL, which they will then call WSL1, with this new version, WSL2. Now, we can still run a distro on the old version on WSL1, or you can run it on the new one, or you can switch your distros back and forth, should you like to do so. Yeah. Okay, so yeah, major asks by customers that we mentioned that. So the file system performance and compatibility, that's where the focus for WSL2 was on. And if we look at file system performance in the next slide, there were a couple of speed tests that were published by Microsoft, and they ran those on a Surface laptop. And what you saw there, for example, a couple of typical things is, when you, for example, get a copy of a Git repository in WSL2, it's 2.5 times faster than it was before in WSL. Yeah? Installing packages, 4.7 times faster. So building a project, 3.1 times faster. So as you can see, it's a lot faster than WSL1. The speed performance is very noticeable. Yeah. So where does that gain come from? Where do those improvements come from? Two main pillars, two main elements. So WSL2 is powered by latest and greatest in virtualization technology. So what better way to emulate something than to actually run it? And that's why Microsoft has also introduced a Linux kernel inside of WSL2. So what kernel is that? It's built from the latest, at the time of introduction, the latest stable branch, 4.19. Microsoft has specifically taken that build and tuned it for WSL2. They optimized it for performance. They removed unnecessary device support, and that, of course, is resulting in that speed, in that optimized performance. Better yet, this is fully managed, so it's secure. It's monitored for security issues. It's being managed by Microsoft. It's being updated by Microsoft, and that servicing happens through the known channels through Windows Update. So yeah, when we talk about the new Microsoft, this is definitely it. Virtualization part, of course, as virtualization and virtualization technology has evolved, of course, we can also build on top of that. So what we're doing right now with WSL2 wouldn't have been possible a couple of years ago. So within the improvements of the virtualization stack, we also got this new functionality. And one of those functionalities is that we got access to a lightweight utility virtual machine. So not a traditional virtual machine as we know it. Let's have a further look into that one. What is that virtual machine? It's a VM that was specifically developed for server scenarios, isolated container scenarios, things like that. It has a low overhead, high density approach, so we can run a lot of containers on a single host machine. Because it's small, because it's lightweight, it also has a super fast boot time. So we can create new containers to quickly spread the load if we have multiple activities going on. Yeah. And we can also run on client applications, so like the Defender application guard and the Windows Sandbox application. Yeah. And then the architecture, we've covered most of that, so let's quickly go over it again. On the left side, the wsl.exe, that's the entry point, the Swiss Army knife for the subsystem for Linux. It's used for listing distributions, as Ken has demonstrated. We can launch specific distributions. We can swap from WSL1 to 2, things like that. That wsl.exe calls specifically into the LXS Manager service, and that is keeping track of what distros are installed, what is installed, what is running, things like that. The host compute service, so the third element that we see there, is responsible for creating and running that lightweight VM with the Linux kernel shipped with Windows inside of it. Yeah? And then the virtual machine with Linux kernel is up and running, and any distros that we introduce are mapped into that virtual machine. Yeah. At that point, after introducing those distros, we are ready to run commands. yeah, we see bash here, for example. So we can do that at that point in time. Now, what is also new in WSL2 is the introduction of the 9P protocol. And the 9P protocol is a file server protocol, and it allows to mount drives and serve files to guests in this specific scenario. Yeah. So whether we access command or we run through bash, through the 9P, which is the plan 9 component, if we refer to it, we can access the Windows file system, but vice versa, it can also be used to access the Linux files from inside a Windows environment. Yeah? So those are the core components introduced in WSL2.
Okay, so when we talk about upcoming features, the integration is going to be better and better and better, meaning that we will be able to really attach the file explorer. We will have integration of the file explorer as we do today with network shares, for example. We will be able to browse our Linux distros directly. We also add some capabilities on the install experience. So we have an improved experience, meaning that we now can install directly from a command prompt. So with wsl-install. So we will be able to install immediately our virtual machine platform and the subsystem for Linux on that. It's another example. So if we open the terminal, we can basically easily install it, and it takes only a few seconds, and then we have our distro up and running. New in WSL is the GPU compute. So we have a lot of customers that are actually using it to basically help them with machine learning projects, but also with for example game development. So EA Sports and I think also Ubisoft are heavily using WSL to basically easily program their games and compile the code in different environments without needing to spin up different development environments, in a matter of fact. The machine learning progress. We really put a lot of effort in this, as this is a very common use case where companies are start to use WSL to understand machine learning algorithms. We even build an entire framework around it to basically help the companies in being more efficient and having a better machine learning experience. There is an entire machine learning stack where we have also added some APIs to do hardware acceleration, and I look with regards to the CUDA driver support. So we have built in CUDA driver support, so meaning that NVIDIA drivers are basically going to be supported out of the box. And that gives us a really nice asset because it will give us the Linux GUI application support. So we will be able to have applications that are running in the subsystem for Linux to have them attached to our taskbar and basically launch Linux applications in Windows 10. That's what in the end. There will be no need anymore to install in third-party Windows display driver. We have ported the Wayland display driver to WSL. In WSL2, it connects the graphical Linux applications via an RDP protocol connection to the main Windows display. So we are actually going to use like a remote application kind of thing. So that means that you can run a set Linux and Windows GUI applications simultaneously on the same desktop screen. So that's pretty nice. Now, and then.
Yeah. So
Tim.
If you're triggered by this session, if you would like to start playing with WSL yourself, what is interesting to know is that you can run this, the whole environment and every demo that you've seen, you could test it for yourself in a virtual machine. The only thing is that you need to enable nested virtualization on the Hyper-V host. You can do that on a per VM basis. So build yourself a Windows 10 VM, shut it down, and through PowerShell, through the command that you see here, the expose virtualization extensions, you can enable nested virtualization on that specific machine. And at that point, you have your own sandbox to start playing with WSL. And I think with that, we are back into our comfort zone and at the end of this session, Ken. We have a couple of minutes left for questions, if there are any. So maybe have a look in the chat first.
It was something else, something different, totally different with what we are usually doing, obviously.
So okay, let's have a look in the chat.
Did they fix the USB comport issues? Not sure, Bart. I need to check. I come back to you on that. Not sure if they have a fix for that.
There's one comment, not really a question. Who would have said 10 years ago we'd be having a Linux session in the Belgian Microsoft communities? We've come a long way, yeah, for sure. Yeah, agree with that. Okay, and the USB COM port issues, they did work in V1, and we can easily switch a comment from Bart on this question. Yeah. And I think that's it for the questions in the chat. If anybody wants to come off mute and ask questions, feel free. Otherwise, Ken, we had a couple of things to stay involved as well.
Yes. So the product team it's Greg actually that is responsible for Wsl. Following him on Twitter. He is really very close with all the feedback that you send him. If you see scenarios that you want to discuss, reach out to him. He's very accessible. And then we have also some documentations, the WSL doc, WSL GitHub, and the command line blog that you can use as a reference if you really want to start playing and discovering more about running Linux on Windows.
Yeah. I see in the chat that Dave also posted a little experience, which we are also a bit familiar with, Ken. So about running the Kali distro and Windows Defender.
Yeah, I was preparing a session last year for a federal organization and about the Windows subsystem for Linux, and I was doing that on my Microsoft laptop, and I thought like, okay, how can I do a fancy demo? Well, let's do some hacking, or so I thought like, oh great, let's install the Kali distro, and I was installing the Kali distro, and then yeah, Kali distro is not an issue. But then you start to install the Kali tools, and it didn't took 15 minutes. I think that I had a mail with Redmond in CC, my manager in the mail, my manager in CC, and so forth and so further. That I was running hacking tools in the Microsoft domain. Obviously, I had a good reason and I could explain, but Defender reacted like instantly on the tools. Yeah. So be cautious when you start playing with the Kali distro in your environment or at customers. They don't like it.
What you can do is configure specific exclusions for Kali Linux on Wsl, but yeah, I'm not sure if that's really a best practice that you want to implement.
Mm-hmm.
Okay, with that being said, I think we are at the end of our slot. So yeah,